Okay class, so here's the deal. You're going to be doing an activity or a handout thinking through kind of this idea of radioactive decay, alpha and beta, and I just wanted to give you another visual to think through, like, what does it mean for alpha decay, for beta decay to occur. So what I want us to think of, so what we're going to do is we are going to use marshmallows to kind of describe or model the idea of what's going on in the nucleus, because that's where all this occurs and all this change occurs. So what we have is, I have two different types of marshmallows, or two different marshmallows that I've changed up. So one marshmallow is plain, okay, and another marshmallow has a little marshmallow attached. So what the marshmallow with the little one attached, what that's going to represent is neutrons, and the marshmallows that don't have anything attached represent protons. So these are going to exist in our nucleus. So let's start off by saying we have, I should probably make just a couple more here, so I'm just going to break these up. So we're going to start off with, let's start, probably don't need too many, but okay, so let's count out our neutrons. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then let's put in 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's put in 9 protons. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 neutrons and 9 protons. Okay, so what is the mass of that going to be? Okay, so let's think through that. So the mass of that is going to be, so 9 protons, 10 neutrons, so that's giving us a mass of 19. And if we have 9 protons, that's going to give us a atomic number of 9, so that's going to be fluorine, right? So that's going to be 19, okay, so that's going to be fluorine. So that's what we're starting with. So that's our pile here of compounds, okay? So that's what we're starting with. Now let's say this undergoes beta decay. So let's say this changes from fluorine, okay, and it is changing to something else. So we're going to change it from fluorine, and it's going to undergo, let's say, beta decay. So beta decay is when a neutron turns into a proton. So how that's going to look. So we've got our nucleus here, okay? It's all of these marshmallows. Okay, so what happens is one of the neutrons, okay, loses this little electron, okay? So if this little electron goes away, okay, that little electron goes away, it's now, what does it turn into? It turns into a proton, because it is now, it has, so neutrons have no charge, but now that protons, now that it's turned into a proton, or now that it's lost this little guy, it now has a charge. So how has our number changed? So if we lost this, has the mass changed? Okay, so did I remove any of the large marshmallows? Okay, so the answer is no. So my mass is still the same. So I still have a mass of 19. I'm going to write this really big so we can see it a little better. So my mass is of 19, but I took one neutron and I turned it into a proton. So therefore, I have one more proton. So therefore, when I had a number of 9, I'm now going to have a number of 10. Okay? So I'm going to have 19 and 10. So that means I'm going to have neon. Okay? So neon is now my new nucleus. Okay? And my other thing, so the other part of my equation is my little electron, or what we call the beta particle. So I've got my starting material, which produces, so that arrow, and then I'm going to have my big pile of, that is the nucleus of neon, but then I need my beta particle. So I can either write it, so one way that we might see it is that just that B, okay, just written as a B for beta particle, but a clear way to describe it would be a E for an electron, a 0 because it has 0 mass, and a -1 because it is a negative particle. So those are two different ways that we might write beta particles, but we're describing that same thing. We're describing that one little negative particle that came off of the neutron to turn into a proton. Okay. All right, so now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 15 neutrons, sure, why not? And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 protons. Let's go with 10 protons. Okay, so we've got 15 neutrons and 10 protons. Okay, so it's a nice big pile. Okay, 15 plus 10 gives me a mass of 25, right? And I have 10 protons. So the atomic number is 10, so that means I'm talking about neon. Okay, so this pile right now is neon. Okay, it represents neon. Okay, so this is going to undergo radioactive decay, and I am then going to produce, but the type of decay that we're going to do this time is going to be alpha decay. And if you remember, alpha decay is the equivalent of a helium nucleus. Okay, so with the helium nucleus, what we're going to have here, don't quite know what I'm doing here, but so my helium nucleus has a mass of 4, and it's helium, so it's got 2 protons and 2 neutrons. Okay, so what that's going to mean is that this nucleus is going to change. It's going to change from being a mass of 25 and 10 protons to being, well, I'm going to need to take, if it's going to have a mass of 4, it's going to have 2 protons, so I'm going to take 2 protons out of this nucleus. Okay, and if it's going to have 2 protons, then it also needs to have a total mass, it needs 2 neutrons. So I'm going to take 2 neutrons as well. So there is my helium nucleus. And then what's left is what I have for my new element. So if we kept track, we could count these all. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 protons left. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 neutrons. Okay, so that means I have an atomic number of 8. Let's see if I can do this upside down. So I've got 8, and then 13 plus 8, that's going to be 21, right? So my new mass is going to be, I'm not going to be able to do this properly. So we're going to have 21 for my new mass. And atomic number 8 is going to be oxygen. Okay. So my new element, after it undergoes alpha decay, is going to be oxygen 21. Okay. So I hope this just kind of modeling or thinking through how the particles change. So for alpha decay, it's literally 2 protons, 2 neutrons that are being pulled off of the nucleus of that. So we started all these things together over here as neon. Okay? But then when it undergoes alpha decay, that means that part of the nucleus, 2 protons, 2 neutrons, shoot out of the nucleus. Okay? So they just go away. And then what's left behind is the new nucleus, this smaller nucleus that's quote-unquote more stable. Okay, so what I want you to do now is work through the handout where you're practicing more of these alpha and beta decays and predicting and kind of noticing patterns as far as how these kind of work out. And I will see you tomorrow.